Problem solving in electrostatics continued. 1. Problem number 1 for today. There is a charge 2q here. There are two concentric thin conducting spherical shells. Thin concentric conducting shells. Hope you understood. 1, 2. Here radius r, radius 2r. I repeat, two concentric thin conducting shells, that is metal shells, metal bodies here. All right. 2q is a charge in the center. All right, here. These things have got plus q charge here, minus 2q charge here. 2q is a charge in the center, plus q and minus 2q are the charges on the two shells of radius r and 2r. All right. And you can say numerically r equals 1 centimeter and q equals 1 microcoulomb, you can consider. All right. Now, just find the heat generated. Find the amount of heat generated when the shell of radius r is earthed. When the shell of radius r is earthed. You connect it to ground, and earth is supposed to be having zero potential. What do you mean by that? See, potential difference is what we important. What is important? Potentials can be chosen any way we want it. Since you could add as much amount of charge as possible, or you can take as much charge as you want from the earth, generally earth's potential will be, the reference potential is taken as 0. Right? In principle, in our theoretical discussion, at infinity we say it is 0. Isn't it?
Yes.
So that infinity could be earth, for example. Okay. And in a practical circuit, of course. I mean, don't say infinity is earth. For the way we discuss doesn't say that infinity is there at earth. Earthing in circuits, of course, the grounding thing has a certain meaning there. I'll come back to that later. Now, it is the situation given in the middle like this. Do you follow? Huh? When you connect it to earth, what do you mean when you connect it to earth? You connect it to a wire, right?
Yes.
So some charge flow happens either from the shell to the earth or through the shell. So the energy present now will be not the energy later. What energy? Potential energy, electrostatic potential energy. So the problem reduces to finding out what? Potential energy difference. Hope you understood. Huh? Hello?
Yes.
So what can I say? Like, what is the main idea to start with? Energy conservation, right? The bigger idea to start with is energy conservation. It's so. So the heat generated is equal to difference in the potential energy. Do you agree? Or and if you can put it in mathematical terms, you will know it better. Whether u1 minus u2 you should write or u2 minus u1 you should write. That you can do. So tell me.
Sir, here the kinetic energy of the system will remain the same.
For the system, the kinetic energy do you want?
Sir, like in energy
It is
conservation.
remaining there.
Huh.
It is like a circuit now. It's not a circuit which moves or anything. It is some kind of a circuit. Two objects connected, and initially the two objects were separate and you connected them to a wire.
Yes.
So if you're asking me how to write that energy equation, I'll tell you that. That's what she means actually, because delta K we write, no, delta K plus delta U equals work done by external, like that we write, isn't it?
Yes.
So here what should we write?
So delta K will be 0 after that.
For the system.
Yes.
All right. So tell me what kind of an equation you write and how do you explain it? Actually, ultimately speaking, U1 you should calculate. U2 you should calculate. That is a beginning. But for better understanding, you can write in terms of equation and check it. First do U1, U2. I'll tell you how to give it a proper mathematical expression. U1, U2 if you calculate, I'll tell you how to use that U1, U2. Come on. Tell me.
Sir,
Something like this we already told children. Something like this we told already. Something like this we have told already. How to find out the energy of the system like this we told already.
Sir, to find the energy, we can find it from potential.
Tell me how to find U1, U2.
First charges, they'll be induced.
Yeah.
Minus 2Q for the inner one. It will become minus Q that time.
So minus 2Q here. I'll write minus 2Q in the solution figure you do, because there's no minus 3Q given. Okay, we'll go to this. Yeah, minus 2Q here.
Sir, and it's given thin shells, no, sir. So one surface only we can consider.
So you're actually on the right line of thinking, but you mean to say I need not worry about minus 2Q plus 2Q, isn't it?
Yes.
Because the radius will be same. So the energies will going to cancel.
Yes, sir.
So I need not have to bother about induced charges. Tell me. That's good actually. Now tell me. So I can write U1 as. So yeah, just take risk, no problem. That let it go wrong. Who is worried?
Yes, sir. Because of like pairs, we can write for potentials or directly energy.
First self energy.
Yes, sir.
K Q square by
2R.
2R for the inner shell. Then
K minus 2Q whole square by 2 into
K into 2Q whole square for the outer shell, right?
Yes, sir.
By
2 into radius of that is some
2R. One is R, the other is 2R, right?
In the figure,
I forgot.
yes,
2 into 2R, right? So self energy, if this is taken, self energy that is taken. Then
for both of them,
and as well
the point charge at the
point
center.
charge and mutual energies. This is self energy 1, self energy 2,
Three
mutual
more.
energy 1, mutual energy 2, mutual energy 3.
Yes.
Self energy, mutual energy. I hope you followed by now. If there is Q1, Q2 like this, K Q1, Q2 by R, you write as self mutual energy, which can be written as K Q1 by R. Here, the potential of this into charge. That's how you need to write. I told you some time ago. Now take that clue and write it. Come on.
For the starting with the point charge and inner one, we get K 2Q square.
2Q by R, no. R if you want, you can, but for this you are writing.
Yes, sir. Into
this is the potential of 2Q at this point into plus Q. Right?
Yes.
This is the mutual energy of this 2Q and plus Q. All right. Then
K 2Q by R.
K 2Q by R.
By 2R, sir.
K 2Q by
2R.
2R, right. Into
minus 2Q.
Minus 2Q, right. Plus.
For that one plus Q will
for
be
the
like
two
a
shells
point
mutual
charge.
energy.
Yes, sir.
K
plus Q will be like a point charge at the center. So
for the external point. So KQ by 2R,
2R into minus 2Q.
Minus 2Q. Come on, add this one. Tell me what is U1. That you find out. Then U2 you should find out. After for that will happen if you connect it to ground like that. What will happen? That's what we need to check. When it is earthed, what will happen to the charge on the inner shell? The potential that should be made 0, right?
Yes.
Hello. So this is the first step, of course. It's not over it. Let us. No, I just did not write the formula there because I wanted you to know how to find this in steps. So 2, when it is grounded, when the inner shell is grounded, when the inner shell is grounded, its potential should be 0. So a new charge will happen. Do you follow? Hello? Hello, tell me, because some charge would flow from there to here or there to here, we don't know. But what we know for sure is that as a result of earthing it, potential of the sphere should be 0. Hello?
Yes, sir.
Yes.
Yes.
So we need to make the potential 0 and get that value, get the charge on the inner shell now.
Yes, sir. Then we can write for self energy of the inner one and again mutual energy.
As usual, we can do that. So how to make the potential 0 there? Hello, tell me. Just you can draw the picture again. Charge on this you can call Q. Hello.
Yes.
And what about the charge at the center? It will be remaining as it is, isn't it? So nothing will happen to that.
Yes, sir. And outer one minus 2Q minus Q.
Minus 2Q.
Minus.
Tell me, what should I do for that? If I put Q here, can I not just keep minus 2Q only here? Because the thickness is plus Q. If I put, you might say some plus Q minus Q if I put, but If I write
sir, I meant if minus 2q, from that we have to subtract how much is going to the inner.
You want to write q minus q here?
Yes, sir, like that.
But ultimately you require the charge on this anyway, no? So you want to write q minus q here?
Yes, sir. And outside, because that small q.
But how much charge going actually does it matter to us? Anyway, I have no problem with that. How much charge q plus q, q minus q, you can write, you mean to say. After that, you'll get the final charge. But finally, you require the final charge on this Sriya.
Yes.
Okay. We'll follow. I have no set pattern to do the question, but I want somebody to speak like that and keep doing the questions. Tell me.
So now we can.
I'll go to the next page.
Sir, here u1 is kq square by r.
No. We need to find out the charge. How much is this u1 you're saying?
Kq square by r.
Really? Did you check it properly? Why nobody else is speaking? I'm telling you, when the inertial is earth, potential is zero, I told. Find out the new charge. I'll tell you the steps, but this better because there's nothing like spoon feeding. Find the new charge. Then find the new charge by making the potential zero. Do you follow? Then find out U2. Then after that, what happens, look, the energy conservation will be like this. Like there's no delta K for the system, basically, like he told. But work done by some external fellow, work done by some cell, if I connect to these things, plus is equal to delta U plus heat generated. This is going to be a kind of a circuit equation for the energy conservation. This will keep coming again and again. Work done by a cell, because we're talking about electricity, no? So that also will be there when you go to current electricity. Plus work done by some external fellow, means somebody may be pulling the spheres apart, something like that, is equal to delta U, that is potential energy change in the system, plus the heat generated. This is the basic equation. But in this case, work done by cell, there's no cell connected, nobody is pulling the spheres, so this side will be zero. So 0 equals basically what? 0 equals delta U plus heat. So heat equals what? Minus delta U, which means
U1 minus
U1 minus U. So your answer is U1 minus U. Come on. Actually, I should tell you this, and then you should work out and come back. And if there's a mistake, I can see that's the best way to do things. Unless the thickness of the shell is given, you need not worry about the induced charges, because they will cancel out. I mean, like for A and B, if the radius, inner and outer radius are not same or same, then the energies and all those things will go away. I'll give one more question. Just look at it and tell me. Shall I go to the next question? No, I just, I mean, because only Sriya was talking, I thought I should not do that. See, others should say something or the other, right? Yeah, I can discuss it to her individually, separately, no? Why everybody else is there? So I've given the clues, you finish the question. I'll give another question like that once again. Can I?
Okay, sir.
Second question. See, a thin spherical soap bubble has surface tension S. A thin spherical soap bubble has surface tension S. Okay. Its surface is charged with charge Q. Its surface is charged with charge Q. Even for this, I'll give the clue. I don't complete it. Its volume is V. Okay. It is found that when Q square is equal to N pi epsilon 0 SV, the excess pressure inside the bubble becomes 0. The excess pressure inside the bubble becomes 0. Okay. Find N. I think I've done this also for you people. Isn't it so? Surface tension.
Yes, sir.
Last time. Tell me. Children. Somebody else. Yeah, let me tell you, because of this actually, this is actual work that should happen, you know. In our senior, what's happening is the people go on listening. Not listening. Listening is good. Listening means you actually focus and try to understand things. People keep hearing. So that's the reason why it's now high time to start physical classes. But since I cannot force all the people to come, we'll once again go on offline online mode. We'll have some classes online anyway, minimum 3 classes a day, but the remaining time will make them do this work. And don't say only work. So the teaching will have, the teaching is actually secondary now for you people. What teaching? You are only listening, and that nothing comes out of it. At the end of it, you don't realize that you did not study. You'll blame people. The total thing is what people call outside is practice. Of course, practice is not looking at solutions or copying solutions or mugging solutions. So we'll have until things become completely clear as to what to do. We'll have a hybrid type of a class. Lot of work will be done. Will make you do there and less teaching online. So decide what you want to do. I have no complaint. I mean, the same work will be sent to you also, but the whole idea is whether you're doing it or not now will be taken care in seriously, because I was trying to motivate you people to involve, but like you don't have that foresight. What happens this time next year, you don't know. You will be pushed to a situation where everywhere you perform badly and you're on the road, like you don't know which college to go. Do you know? Ask somebody with experience, they will tell you. Like say you perform badly in every exam you wrote, and you don't know which college to join, and you'll ultimately blame Corona and then the college, which is happening with some people now. And people forget that Corona is same for all. The conditions are same for all. Any competitive exam, apart from the maths, physics, chemistry are doing, there is a psychological factor. For the fourth subject, I say, you may be getting marks directly in the exam, but remember, you are indirectly getting marks for your strength of character also. So somebody cannot say, I went to the exam, got tensed up. So because you got tensed up, definitely you are short on something, so you are penalized. That's my way of looking at it. You are taking your work seriously. But the way you are responding to me in the classes when I solve some good problems, I can feel that nothing is happening from your side. Practically nothing is happening. That means you don't have a plan, you don't have a future plan for yourself, you don't have a foresight as to what will happen after 1 year with me. What will happen, I tell you, if you continue the same way, what is going to happen? If your parents are there, call them to hear this one. You will perform badly in IIT-JEE mains. Even if it is conducted 4 times, your percentage will be less than 90, and which will be not useful. And your MSET also will suffer. And intermediate also may suffer. So ultimately, you become so bitter and bitter about others that you'll keep blaming everything, but you don't take the responsibility that you did not work. I'm telling you again and again, if you people just are like this, actually my last lesson is over. I can throw the assignment. I'm not throwing for that reason, because in second year, ultimately, you should have understood by now that no, whether I sit at home, whether I go to the college, I'm going to write an exam later. If I'm going to write an exam later, I have to solve problems, I have to do things. All that should be understood by you. So I'm trying to initiate that process of thinking and problem solving, for which you require to talk. You need, see, in a physical class, you can do and bring it. Sir, I did this work. But here, the only way you can improve is involving yourself in the discussion. And some of you would like to involve, but you're not, because nothing is there in your brains. What all is done in the old classes is gone. You're only listening. How will listening work? Huh? Hello. This requires certain things. Look. What the idea, the setting up the solution, I'll tell you. There is a soap bubble like this with sigma charge density. He has not given the charge, but supposing it has got charge, there is some charge density. Right? And yes, it also has what? Surface tension. Isn't it so?
Yes.
Ordinary soap bubble, there's no charge, net charge, but supposing it is charged, something else will happen. There's a P inside, there's a P0 outside. Hello, children. Huh?
Yes.
Soap bubble with no charge, if I write. Soap bubble with no charge, P minus P0 is equal to what? Tell me if you remember. No one remembers. So the formulas only you don't know. So what kind of work are you doing?
2T by R.
No. 2T by R1 plus 2T by R2, 4T by R. Because soap bubble is supposedly having two surfaces like this. R1, 2T by R1 plus 2T by R2. If R1 is approximately equal to R2, it is 4T by R. That is 4S by R in this case. If it is without charge, with charge, what happens? With charge, like if I had charge on this, I'm telling you the idea of the whole problem. It's a good, beautiful question. Nice question, actually. This, I mean, exam-oriented students, I mean, the like subject at the same time, they also would like to talk about certain good sums. They'll take this as one of the good sums. Now, once charge is given, what's going to happen? Huh? What is going to happen? There will be pressure developed because of this excess charge also. No, sorry, charge also. Hello.
Outside the pressure will change.
No, this P and P0 are still same. That doesn't change. This placing charge will also cause pressure in the film. That's what you need to understand. Look, the soap bubble gets stretched because of the repulsion of the charges on each other among themselves. Do you follow? Hello.
So to make them perpendicular to the surface?
Not. I mean to say, yeah, all that is there. But my point is, even if they are like this, once the electrostatic equilibrium reached only, there's a repulsion, no, between the like charges.
Yes.
So once you charge it, there'll be a little what? Stretching of the soap bubble because of the repulsion. That's what I'm trying to tell you.
So will the bubble expand?
A kind of expansion, yes. I mean, of course, we don't say R1 now, R2 later, but it expands, yes.
Yes. Okay.
Like, if you say R1, R2 are coming into picture, we still take that R only later.
Yes, sir.
But in fact, it is expanding. So it is stretching, isn't it?
Yes.
Yes.
Hey, come on. So what will be that kind of what is that force there? Does it cause some pressure towards outside on the bubble? Take some small area here. Will all the charge on that will push it away like that?
Yes, sir.
Yes, sir.
So that force by area gives pressure here, right?
Yes.
Do you follow?
Yes, sir.
Some remaining charges E1 will be there like this. Even into this charge dq will be there. That by this area is a dp like that, isn't it? This area is a. Hello. Keep listening. I'll develop the whole question in a beautiful way. I went for this first statement. This is the first thing. And we know we have taken this formula from the surface tension. Now we charged it. Once you charge it, the repulsion among the things will be stretching the film, right? Hello.
Yes.
They try to move as far as possible, so they will stretch the film. How do I find out that pressure happening because of that? I'm saying I'm considering one small area here. And this small area film, there is E of the remaining, isn't it?
Yes, sir.
That will apply a force E1 dq by A, I'm saying. E1 dq, and by A, this area with the pressure that side. So what should I write now? Of course, you need to find out that pressure, basically. That dp, I'll say. Or the pressure, if you want, total P. Electrostatic pressure, that is, we can call it. What is that? You can say some electrostatic pressure. I can call it P, and it will be away. So what should I write now?
Sir, we can take many elements. So
No. That will come back later. Let me set the question. I don't know how much is it. That's a different case. That will come next. So try to understand the way I'm analyzing the whole situation. So that is P outside, like P electrostatic, I'll say outside like that. Now, how will I write my equation? How will I write my equation? There is a P here. There is a P0 there. So what should I write? P electrostatic plus P minus
E minus
P0.
P0.
Yes, sir. Will be the surface
Is equal to 4s by r.
R.
Tell me, children.
Yes, sir.
Hello.
Yes, sir.
Tell me.
So due to the additional electrostatic force after the
So
charge is
we need to,
placed,
and of course he says this should become 0. That is the main idea. Do you follow? What he says is the excess pressure inside the bubble becomes 0. This excess pressure is there now. This should become 0 because of the extra electrostatic pressure he's saying. So if this is becoming 0, finally what do I get? P root electrostatic should be equal to 4s by r. So the problem reduces to finding out P electrostatics. Hello.
yes,
This is what you mean by setting a question. Actually, I've given the formulas in the middle. I should not. You don't require formulas to set up a question. You require the idea. So it reduces to that P electrostatic extra electrostatic pressure is equal to 4s by r. So I can make one more problem out of this. The first question could have been only find the pressure due to the charges on this could be a question. Now I'll go back to this. Look, it's a nice way of doing things. I've got a shell of charge like this. I don't know whether people are listening only. I would try to find a person who is actually understanding what am I saying. If you go on discussing things like this, there won't be new question. I mean, new question means questions are new, slight change will be there, but physics is that way easiest of the 3 subjects. You get a same question with a slight change. So I'm talking exam requirements only, but for that also required to understand things. Now inside, tell me what is E? 0. Hello.
yes,
sir.
So if I think of removing this here, because I want to find out the field of the other due to this, not removing actually, field of all this and field of all this should be 0 now here. Hello.
yes.
Tell me. Hi children, do you follow?
It is like a shell only,
like my point is, if E has to be 0, E due to the remaining and E due to this must be equal and opposite, right?
yes.
Yes.
Tell me. The idea once again. Tell me whether you understood.
So if it is 0, then totally it will be 0. So even if one part is taken out, then the E by that
We want the E of the remaining thing so that I could use this formula. E1 into dq by A will give me the pressure. That's what my point is. E1 I want to find out how. Even if all this will be opposite, I mean, this way. Sorry. Yeah, it's away. And this will be away. So this is E1, this is E2 due to that. So, but E1 minus E2 should be equal to 0, right?
yes,
Yes.
Do you really follow?
Yes.
If I take
yes.
the small, see, I told you already, this whole thing's E is acting on this. That is applying a force E1 dq that way. By this area, I'll give you pressure, I told you. So ultimately, I require to find out this E1. Hello.
Yes.
Do you agree, everybody? So E1 equals E2 like that. Huh? Hello.
Yes.
And for a shell, what do we prove the E is for one layer? Hare, do you follow? Hare, come on. For any shell, E is 0 because I can think it to be having two parts. Sigma by 2 epsilon 0 this way, sigma by 2 epsilon 0 that way. But for a shell, what happens? Outside, sigma by 2 epsilon 0 of two shells add up. Inside, they cancel out. Isn't it so?
Yes.
Hare, this we've been talking so many times, Sriya.
Yes, sir.
Whichever way you take, whether you take this much doesn't matter. If they are cut, field will be there on two sides, which is equal to sigma by
2 epsilon.
2 plus 0. When you join,
It will become 0.
0 inside and outside it becomes sigma by
Epsilon 0.
epsilon 0. Do you follow this?
Yes, sir.
So E1 at this site will be what? Therefore, pressure due to electrostatic will be, what should I do? E1 is sigma by 2 epsilon 0 into dq by area. But what is dq by area? Sigma again. So sigma square by 2 epsilon 0 is the pressure due to the electric force. That itself is a single separate question. Do you follow? That's a separate question itself. If I have a shell which is charged, what is that pressure caused due to the electric charges? If you say that is sigma square by 2 epsilon 0, that's all. Now, what will I get? Sigma square by 2 epsilon 0 is equal to what? 4s by r. Hello.
Yes, sir.
And how much is sigma q? Q square by q by
2
a.
epsilon.
Sigma is charged by surface area. So q square by 16 pi square r to the power 4, isn't it?
Yes, sir.
Array, sigma is q by
Q
4
by
pi
A.
r square.
Yes, sir.
By 2 epsilon 0 is equal to 4s by r. And what did he say for q square?
N pi epsilon 0 S.
And now, can you complete and tell me how much is n? Numbers.
Sir, here on the right side, where we said E1 is equal to E2, so that does not depend on the area we take.
Nothing. That's the whole idea. Sigma, we're giving in sigma terms, right?
Yes.
So q by a will be same all over.
Yes, sir. Since sigma is constant, it won't matter.
Yeah. Come on. Actually, even if I wanted to complete, my space is over. I don't know whether you understood. You want me to complete it? I'll complete it.
Will do.
Actually, I ask one of your parents to when I'm teaching. Actually, they'll know what, because it's becoming thankless, completely thankless job. Like no response. Whatever I write, you just write. No trying from at all from your side. So it gives n that way. So I'll write n pi epsilon 0 s v 4 by 3 pi r cubed by 16 pi square r to the power 4 1 by 2 epsilon 0 is equal to 4s by r. Is that all? Any numbers were given? I don't know. So pi goes, tell me.
Sir, I'm getting 90.
S goes, right? Epsilon 0 goes. What else?
Sir, 4.
48 to
Sir, 4 and r cube also get cancelled.
4 and
R cube.
where 4 is r to the power 4. This is.
Sir,
Sir.
right side.
Okay, you mean to say there will be one r here. Is there any other r? This r also goes.
Sir, right hand side. Yes.
So this is.
Sir, 4 also and pi.
This pi also goes.
And 4 as well.
This 4 also goes. So 48 to 96.
Yes, sir, 96.
Right. So this calculation. So just one question, how many ideas can you see? Huh? The excess pressure in a soap bubble. The electrostatic pressure developed for a shell. Huh? And then the E of a conducting shell. And E of a conducting shell for 2 different layers. So this is equal to some 10 questions, do you know? Not one.
Sir, when the Q is added and it expands, if we take 2 radii, that is like R1 and R2.
You can find out some difference in the energy, and that can be the energy released as heat. You know, which may be what you call compensated by the energy absorbed by the film from the surroundings. Hello, I told everything there. KQ square by 2R is the energy. So if
yes.
Q will remain same, but radius is changing. So KQ by KQ square by 2R1, KQ square by 2R2. So
yes.
that difference will be the heat generated. Do you follow?
Yes, sir, that I understand.
Then what are you asking?
Sir, but then when we're calculating for excess pressure,
Huh?
When we are calculating for the excess pressure, here we'll get different, no, sir, 4s by R1 and 4s by R2.
No, that we are ignoring, I told you already. Huh?
Yes.
There nothing is mentioned about it, right? That in the very beginning I told you about it. Huh?
Yes.
We are keeping it same R, though expansion is happening.
Yes, sir. Okay.
So one problem, you should have learned something. Okay. No, even if you did not learn in a serious way, if you're exam oriented, now your mind will what you call, grab few formulas. Excess pressure for a soap bubble, electrostatic pressure for a shell. Like these formulas it will catch. And remember, at some lower level exams or even higher level exams, few questions are going to be straightforward questions like that. What should I do with you people? You're not responding. All right. Can I go to next question?
Yes.
Yes.
One more question at least we can try, I think. Yeah. Look at this. There are two shells, conducting shells. One, this is thin, inner shell is thin. The outer shell is thick. That means you need to consider the radius. You need to consider the radius. Okay, this is the outer shell. You understood. Let me see if I have the radii given. Yeah, this is inside is A, right? This is 2A, and that is 3A. Okay.
Yes.
Yes, sir.
The outer shell is thick and has a total charge of Q. Inner shell is thin and is earthed. Find the charge in each surface. This is a very basic question. Yeah, the question which I gave you could have been done if you knew this in advance. Find the charge in each surface. Right? The whole idea is this. The starting point will be this. Once you ground it, potential of this will be 0. So you need to make the potential 0. For that, how to put the charges, you need to understand. Do you follow? Hello?
Yes, sir. Like the previous.
Yes. So, can you make it fast? Find the charge on each surface. That's not so difficult. It's a fast you can do. You just tell me, what should I do? If you think there's a charge Q formed here, hello. It will have minus Q plus Q like that, isn't it?
Yes.
That's why the thickness of the shell is considered. The radius are different. Do you follow now?
Yes, sir.
Now write the potential on the inner one quickly. Potential due to this, potential due to this, potential due to that. Hello, quick. 0 equals
KQ by A
KQ by A
minus
minus KQ by
2A
2A plus K into
Q plus Q by 3A.
3A,
Yes, sir.
right. So tell me, simplify it and tell me. We want Q. KQ by 2A, KQ by 2A, KQ by 3A, 5QQ by KQ by 2A, 5QQ by 2A. 5, tell me. 5Q by 6, isn't it?
2q by 5.
So 5q by 6 equals minus q by
3.
3. Right. So
Minus
q
2q
equals minus
minus 2q by 5.
5. Is that correct?
Yes, sir.
So accordingly, you put all the charges. Hello.
Yes, sir.
So that's one trick again to find the charges. So once again, I'm telling you, the classes will start. We have a particular method now to make you work. But who would like to stay at home, kids can still say no compulsion. So online classes will happen and offline work will happen. And don't anybody take an excuse that classes are happening there, no similar, no, like we are doing now. That's not the basic point at all. In fact, I'll reduce those classes and increase the working classes now. And Shreya, tell me,
Yes, sir.
isn't your understanding improving after you're working?
Yes, sir. That is definitely.
That's finally, people don't understand it. Like one parent was talking to me this today. I mean, last year parents. Sir, he did not get anything, sir. You said he'll do something. Like he's making it my problem and indirectly. But that fellow did not work one day. Huh? And he says I should somehow make them work. If I knew the trick, I mean, that's great. I mean, like somehow if I make you work without you wanting to work. But at least I can tell more inputs about you if I'm watching you from the over your shoulder. So the classes will be there. All right. So you decide when you want to come, that's all left to you. People can come also to the hostel, there's no problem. Like last time, girls maintained very strictly. I mean, nothing, I mean, in the hostel, nowhere girls had any issues. Boys, 1 or 2 boys, of course, did not maintain properly. Isn't it, Aryan? You are the first one who was opening the, what do you call this, mask very frequently. Did you?
Sir, actually, there was suffocation, sir. That's why.
But that
I used it
suffocation
to.
we are also facing, no? I've been imagining for the last 1.5 years, I'm doing all my work. I'm going to hospitals, I'm going everywhere. The last 4 days, I've been in the hospital for hours until 2, 3 in the nights. I had to be. You're sitting in that. We can go and sit in the top floor, open everything. So many rooms and less number of students. So why should there be any infection at all? Of course, that time it was different. It was flaring up, like it was coming. It was the worst time, of course, for the second time. But this time it's down. And if you're already 18, take a first dose of vaccine. Hello. So we'll start the business, right? Any problems? If you have any issues to talk, you ask your parents to talk to me individually. Okay. Government actually allowed with the conditions. So we thought, of course, we'll postpone by 1 week, but no. Apparently, Bhaskar had told, it seems, but now I think we need to start. There are no difference. Those interested will come, those who are not interested will sit at home and work. What is there? We'll also give the same work to everybody. So whether they work or not, that's their problem. Okay. No force, no compulsion, please. Do you follow?
Yes.
Right. I'll close it. We'll come back tomorrow.
Thank you.
Thank you.